to turn on video. Okay, so this week we are going to work on wireless LAN. This is an area that we briefly mentioned in the prior chapter. So please download the notes and the assignments. We'll go through that together. And as I said, we're going to do Cloud Lab this week, as I have a meeting at an extension of MVC, which is at Ben Clark Center. So I won't be able to hold class, but I want you to have exposure to Cisco device, especially in the terminal, as most of you will be working in this area for cybersecurity and IT. So this week we are going to cover chapter 10. And as you notice that we don't have that many chapter left. There will be 1 week that we'll do 2 labs. So I want to give you more hands-on. So I will make sure that you're aware of that. So in this week, on the wireless, we want to dive into a little bit more about the technical side and how to work with wireless, especially this is a very much required area for your position in cybersecurity and IT. So wireless LAN, it uses radio frequency, your RF, and it uses air to carry out your frequency. As you know, right, just like any form of signal, whether it's wired or wired, eventually you are going to have some degradation in signal. That means that sometimes you have bounce in signal, in that when you use wireless in an area where you have metal plates, that's going to also bounce your signal. Glass, water fountains, big ones, right? Like you've seen companies that they would use water fountains when you enter for decoration purposes, but they also use it for technical purposes, right? To be able to shield signal and so on. So there are factors, environmental factors that we should consider when we install our access point and our wireless routers. So when you're using high frequency, that's going to give you, of course, a lot of throughput, but this, as you know, as we move away from the source, we're going to lose the signal. So this is where the antenna comes in. So most of the devices that you see out now for wireless, when they come with antenna, they will come with omnidirectional antenna. That means that it is covered in all 360-degree angle. But in some cases, we would see semi-directional antenna. You want to use your antenna for the purpose of your wireless networks, okay? So for example, when you go into the hospital, normally they would have a public network for patients or visitors, and that will be limiting to a certain activity that they can do on the wireless network. Of course, it is open to the public, so you would have higher risk. Then they have a network that will be for physician nurses, the staff, the people who work there. So now in the hospital, you know that there are scanners, devices, equipment that cannot have interception of other signal because they are operating at the same frequency and channel. So for example, like a lot of the CT scanners, a lot of the health scanners would require you not to have any kind of impeding in signal. So in that case, around those rooms, you would see a blocking of your wireless signal, or when you go in there, you won't have any kind of cellular or mobile signal along with the wireless signal. So in that case, we want to use directional antenna that will point to only specific area that we want to broadcast the signal, okay? So you would see sometime that will be a single direction that will cover at an angle range, meaning that I want to only send the signal maybe at 45-degree angle, not 100-degree angle or 180-degree angle. So we can use the antenna toward the direction that we want to send the signal. Hello. And so therefore, it's important to think about how you use your antenna, how many antennas is incorporated for the device. Some device would have the attachment in antenna, and then some antennas actually built inside the casing of the device. And it will tell you the specification on the box or on the information of your manufacturer website. So here are some of the agencies that govern the wireless signal, okay? So you know the IEEE, they are in charge of creating, maintaining the standards like your 802.11.x, right? Like 802.11ac, 802.11b, etc. So they maintain the standard. Then in Northern America and also in just United States, we have Federal Communication Commission. They actually overlook the regulation of your wireless devices. As you know, that Amazon been trying to fly drones to rural area to deliver packages, right? Because FCC regulates that they cannot fly over flight zone. That means that anywhere around the airport, anywhere that would cross into the pathway of flights, and also military air bases that can prevent issues. So FCC control how we're really using the wireless devices and how that can be implemented in facility physically. And then you have the Wi-Fi Alliance. These people are they test your actual wireless device. Now, not all of them are tested. Normally when you see a device that's been through the test, the label on the box of the device will say so. The manufacturer can sell devices that are not fully qualified for Wi-Fi Alliance. But the ones that are tested, usually you see some costs that's going to be included in the actual device. And then you got the WLAN, that's going to be your association. This allows us to really raise awareness about how we're using wireless signal. Okay. All right. So here there are some information about this. So most of your devices uses these bands. Okay. Now you do have interference in signal, especially if you're using cordless phone, right? Or devices, other devices that are using that particular band. If you experience this all the time. If you listen to AM, FM radio, when you're crossing a certain area, right? It sounds like, you know, either your station is degrading in signal or there's a cross talk in the station that's coming through. So you sometimes will have an overlapping in the band that causes the signal to have some kind of interruption. So in that case, we have to be aware most of your appliance, okay, and on wireless level, including your smart TV, operates at 2.4 gigahertz. Even though we have 5G, many of your devices are not equipped with 5G unless it's newer and it's smart devices. So if you're using like, you know, an old laptop, if you're using an older device that have wireless capability, likely that you are using 2.4 gigahertz. So when you connect these devices, you have to think about making 2.4 gigs available along with the 5 gigs as it is dual band, right? Because you want to make sure that you are scaling from legacy devices to the newer devices. So that's important to think about. Okay, so let's answer some questions now. So in chapter 10, for number 1, we need to explain the relationship between frequency and distance in wireless networks. So when you're using higher frequency, signal is transmitted in shorter distance. So when you're using 5 gigs, that means that 5 gigs is not going to be able to send signal farther compared to 2.4 gigs, right? So when you're using shorter distance, we can send stronger signal with the higher band. When you're using lower frequency, like 2.4 gigahertz, your signal can be transmitted in a longer distance. So there is an indirect relationship between frequency and distance, and we have to be aware of that. So if you only turning on 5G, right, keep in mind that you are going to have shorter distance in how the other devices will be able to see your access point or your wireless router. Now you can implement signal amplifier, right, to be able to relay that signal across a longer distance, and that's what we normally do. So it just takes that and repeats the signal and amplify the signal. But anytime that you're using higher band, you know that you are going to deal with shorter distance. And if you're using lower band, you're able to send it further distance. So therefore, coming back to your AM, FM radio, right? The frequency on those bands, how they're using, if you drive around, right, they still have radio tower to be able to broadcast analog radio. As you would see that they use those towers to regenerate the signal, and those signals are often in the lower band. All electrical signal, right, uses some form of frequency or emits at a certain frequency. And so for wireless, we are looking at, right, between 800 to 2.4 gigs. Normally, it functions best in 900 megahertz until 2.4 gigahertz and higher, right? So the type of facility that is ISM band that's used would be your office building, your healthcare facility, your warehouses, and even your homes. And we'll talk about ISM band. Any questions? So I'm pretty sure that your Network Plus certification, if even with the newer version, will ask about wireless because wireless is prominent in today's network compared to years ago, right? It is affordable to implement almost all completely wireless now, right? About 15, 20 years ago, it is not possible to do so. But ultimately, your wireless appliance is still going to connect to your backbone, which is your wired network, right? And your wired network is always going to operate faster and more reliable. Okay, so here's the ISM information. This was established in the 90s, right? And the majority of the time back then, they really use this as for industrial purposes. But you know, university would use it, like UC Berkeley, they would use it to connect you know, smaller buildings, and then you would see that in healthcare facility like hospitals, and then warehouses for manufacturing. So when you're looking at the AM broadcast, if you ever listen to a AM radio station, this is where they actually operate on the lower band. For your FM, like all the station that you listen to on the radio when you drive to school, work, right? It is a little bit higher on the spectrum in compared to the AM. And then when you move into the cellular network, that is going to be 840 megahertz and higher. So your wireless actually operates between 900 to 2.4 gigahertz. And then now you also have the 5G band. And then anything beyond that, that will be your infrared wireless X-ray. And so this is why hospital blocks signal in the areas of X-ray machines, because there might be frequency crossing. And when you have frequency crossing, it causes interruption. Okay. So on the spectrum, you would see it like this. Now, if you notice that now our government and a lot of places are still, they're using drone part of it, okay? And drone that uses a different classification in wireless, it uses Zigbee. And so you've ever seen video where they shoot down drone, right? So basically it is an interruption in signal. So when you emit a certain signal, right, to interrupt a signal that's sent from the controller to the drone, a lot of the times, you know, your toy drones are like controlled with Bluetooth, and then it uses Zigbee in the back. So on the industrial drone, if you see the drones that flies around that record video that, you know, the government uses for warfare purposes, uses Zigbee. And in the area, the drone, you normally see that it usually is shielding in some of the signal. So for the people who puts up the controller for the drone, right, because it emits at a certain band, they have to make sure that they control the band range, so that way it won't cause interruption. And you do see a lot of this in cybersecurity now, where we think about like how we can prevent things from interrupting drones, or things that would emit signals that would prevent drones, because drones is being used quite a bit more frequently. So when I teach like graduate level or bachelor degree classes, we do more projects in that area. when we look at the wireless band for drone, because you do see like there's a need for it. So when you're looking at this, this tells you the 802.11 classification, right? The AB is the earlier, and then we move into the G in the 2000, and then the N in the late 2000, and then when you now what you see is the AC. There are other classifications that are not authorized to be used for consumer purposes. Hello. So you do see some proprietary network range, okay? And then we do have radio frequency for our wireless. Now on the cellular end, for those of you who are growing up like about the same time I did, or even earlier, maybe your parents or older siblings might know, right? Many of us grew up with GSM networks. So that was for your cellular subscriber system. And the GSM was predominantly with T-Mobile, AT&T, some of those networks, the networks that use the SIM cards, that's what you see today. Right now it's integrated for the UC, which is what you see with the 5G. But FDMA, Verizon actually tapped into the frequency division multiple access. That was really their network technology at the beginning, and then eventually transition from 1G to 2G and so on. So the G really represent the frequency that we use. And remember, I talk about how there is a relationship, right, between the frequency and the distance. So now we're able to integrate technology that allows us to support the mobile networks in a higher frequency. So therefore we can transmit data at a higher rate, but we would have to have more frequent cell towers in order to really support that, right? So when you drive around, you start to see more big palm trees that comes up and so on, right? And the physical security in that is really important because they can take out our cell tower and they can cut our communication for the region or even for the country. So, you know, there's a lot of talk about how we can protect those type of systems that exist. And then within that, you also have switching network that's integrated with the cell towers to be able to support the larger network itself. And then we move into the CDMA, which is what you see as a later integration. Then your LTE before the UC. So for those of you who use T-Mobile like I do, right, you've probably seen LTE a while back, right? And then now we, and that transition to some GSM Edge and then your MTS. So ultimately, all of these are ways for us to be able to convert your analog to your digital signal and how it can send that across the frequency. So the main area with FDMA is that because of the way that we divide up the speed this way, it's gonna reduce the eavesdropping. So when you eavesdrop in security, basically you're tapping into some system conversation. It doesn't have to be a voice call. It could just be like traffic communication between the systems. So TDMA was an integration that boosts the security side of the house. And then earlier on, if you're taking a look at like how the SIM chip was actually integrated, and then cryptography was implemented. So when you're looking at like the first iPhone and iPhone 2, iPhone 2 was actually not difficult to crack, right? One of the famous hacker hacked it in 24 hours after it was first released the first week. So what you see is that nothing is unbreakable. What we're trying to do is we're integrating things in communication that allows us to be able to send more signal or ultimately data, and then to be able to protect our data. Okay, so here lists the table of standards. As you can see, there are other standards that we haven't seen from the consumer side of the house, but you do see some of the common ones. So they actually classify others based on the table. So what you're using now is AC, and AC is here to stay for a little bit. I think that they're working on the next classification, and you will see that. So as we need more, more data, more communication in our network, you do see additional classification being allowed. Okay, So for question 3, the type of cellular network used for 5G, as most of you are now using 5G, your CDMA, which is assigned for unique code, each call or transmission. So when you make the next phone call on your mobile phone, you should think about CDMA, how that's integrated, right? It is a way for us to code, give it a unique code for that particular call so it can be tracked. And then to be able to spread the data across the spectrum. And so it uses all frequency because otherwise we're not capitalizing on the range of frequency that we're using, right? And then your LTE, that's your long-term evolution. And this is going to be your standard wireless broadband communication for mobile devices and your data terminals. This is originally based on your GSM Edge. So from Edge and GSM, that was integrated into LTE. So for those of you who have like T-Mobile, AT&T, you saw that, right? When we use it at 4G, was transitioning over to, and then eventually LTE, and now I think it's UC for unified communication across. So they have decided that why are we integrating all of these technology for different mobile networks? Let's try to conform it and make it all one so that way it is interchangeable. So your UMTS, your HSPA technologies were also incorporated into LTE, okay? There are specialized people that focus specifically on wireless adaptation, right? So whenever we rolling from one band to the next band, normally, right, we want to test in a certain location, so geolocation, and then incorporate. If you look at Asia and Europe, they're actually a little bit more advanced in how they integrated the signal. So for example, 2G and 3G actually rolled in Asia 2-3 years before the United States. Because in the United States, there are regulations that restrict us from implementing quickly before proper testing that relates to health. As you know that, people talk about like how these emission of signal can cause cancer or, other things because it is radio frequency. So before we roll, like we have a lot more restriction in North America, including Canada, compared to Europe or Asia. This is why you do see the mobile phones are being released in other countries and other parts of the world before United States, is because they actually adapt the technology sooner. I actually have friends that integrated, the 2, 3, and 4G in Asia and Europe, and that was their projects, right? And then I actually know people who formerly owned Cricket Mobile, and the actual CEO of that, and then he sold to now what you see with Cricket. So you do see integration a little bit different in different part of the world. And so what you have to do is you have to look at the local requirement. All right. So for Network Plus and for our final exam and quizzes, we need to know the different classes in your 802.11 classification for IEEE for wireless. So the wireless standard that transfer at 11 megabit per second, that's going to be your B. Okay. This was widely adopted back then because the cryptography that incorporates with it, we moved from WAP to WEP and then now WPA. So we are advancing in how we are protecting and encrypting as far as access goes. And then for the wireless standard that transfer at a much higher rate is 54 megabit per second. And it is backward compatible with B. So from B, we transition to G. And G allows us to transfer data at much higher rate. So many of the organization actually implemented G. They waited for G instead of incorporated B. And by the time that G hits the market, what you would see is that you would see more abundant in wireless devices, like your wireless router for home use, your wireless access point, and then also adapter or mobile devices that came later. And then after G, you have the N, and N was transferring at the same rate or N even higher. So we were able to reach 1.5 gigabit per second at one point at the end of N. And the only difference too, besides the data transfer rate, is that N incorporate higher or better encryption or cryptography technology for wireless access. Okay, so as you are typing this down, we're going to talk about channel, okay? Because you've seen this when you look at the configuration for wireless. So I want to make sure that I touch back on this so you understand. So if you are looking into the detail for the classification, start with 2.4 gigahertz, and I try to group them together so you can read them all together, right? Like the B. Remember that it uses the carrier sense multiple access with collision avoidance. This allows us to have collision in the traffic. So anytime that you see this in an appliance or technology, that's always better for us in the network. You don't want collision, and that causes loss in traffic. Okay. And then how does it do that? It actually sends signal for, request to send and request to clear to send. So it has confirmation on, before it sends and as it sends. Like this. So once it does that, so request to send, once it acknowledges the send, then it's clear to send, and then your data comes through. And then the acknowledge that the data is sent. So we are able to track and avoid error this way. Okay. All right. And then the G information is here. Remember that it is higher rate and it is at 2.4 gigs. So here are your channels. So in United States, only 11 channels are configurable. Okay, that's important to remember. These are 1, 6, 11 are overlapping. So only these are going to be overlapping out of the 11. Okay. So when you configure, a lot of the times your router, your wireless router, your access point will have a default channel that you can select other channel. So if I'm having a lot of crosstalk or interruption in my signal, I would consider reconfigure with a different channel. Okay. So the only ones that are non-overlapping is the 1, 6, and 11. So as you can see in darker circle here, the other ones are all overlapping. So if you set it on channel 4 and you're getting like cross signal, then you need to consider setting it on the non-overlapping for your wireless network, like the 1, 6, and 11. Okay. And this is, on the newer devices, it would list a lot more. And if you work with the older devices, it's only going to list some of the ones that are allowable for that particular classification. So here I put an example. It says, if you configure one access point in channel 1, then the next access point must be configured at 11. And the farthest one would be configured on the first access point. So because this channel is going to be the farthest that configure on the first access point. Okay, because these are overlapping. So if I have an access point that's configured on channel 1, right, you would need to go to 11 for the next one. Okay, we don't want to have a bunch of access points that have ones, right? So you want to go farther because you don't want crosstalk, you don't want overlapping. Any questions? Understand that concept? Okay, so let's come back now to that, right? So for number 6, this is how many channels are configurable in the United States and what are they? 11 channels are configurable because they are overlapping in 2.4 gigahertz frequency. I think I put this on. So hold on 1 second. So 1, 6, and 11 are non-overlapping. And the others are overlapping. So only these three are not overlapping. Your 2, 5, 7, 10, 12 to 16 are overlapping. Then for question 7, it asks you, Teresa configures an AP to use channel 1 in the building. If she needs to add another access point in the same building, what channel should she use for 802.11g standards? And we saw this in the notes, right? Channel 11, because it's the farthest from channel 1 to prevent overlapping. Any questions? All right, remember 1611. Okay, so now, as you can see, it's going to give you the breakdown of the 5G. So earlier on, they implemented the A, which was the very first, right? I want to say at the end of the 1990s, and then going into the early 2000s, it was transmitting at 54 megabit per second. However, on the A, the downside of that is that the next to no encryption. And then we implemented cryptography for A, but then easily broken. So when you're operating at 5 gigs in the radio band, even with A was immune to some interference with the devices to operate in a lower band, such as your microwave oven, your cordless phone, your Bluetooth devices. Remember that Bluetooth is also in that range. But what Bluetooth does is it is an ad hoc hop in the channel. That means that it will pick up the whatever that's available, and it changes all the time. So once you sync with that, right, and it's only going to be 1-to-1 compared to your wireless router or your access point, it can accept multiple requests where it can be centralized and be able to service multiple devices. Okay. Now, so for 802.11a, because it can, so the maximum capability is going to be 54 megabit per second. But from my experience, it's only going to be reaching at the optimal level. At some point, you do see that it is transmitted at a lower rate. It depends on how far you are from the access point, of course, right? You see those little bars when you move far away from your AP, right? They reduce. And then the H was integrated, but never fully used. It had more non-overlapping channels, but we didn't really see this in the consumer market too much. Okay, so it talks about transmit power control, and then the wattage that it was used. And I think that was the concern in some area related to how that was tested. It was not fully integrated for use in the consumer world. And then your N was very popular before the AC. You might find some old stuff at home that might be using 802.11n. Slower, it does use the MIMO. Whenever you see MIMO is multiple input and output. You probably learned this in CIS40A. And it has a way that we can do channel bonding because it carries, it does allow you to be able to transition to a higher frequency, adapting to AC very well. Okay. It also integrated the MAC efficiency required acknowledgement for the frame. So it does work with the lower data frame level. This was something that they incorporated for N, as we want to be able to filter and control more access on the data frame. So this is how you can also MAC filter. Okay. So Wi-Fi stands for wireless fidelity. Make sure we know this for Network Plus. Okay. And that is tested and passed through the Alliance. Then it talks about your AC. Now, AC, you know, when the rating for the transmission, you always gonna see that data is tested and shown as the optimal level, right? We don't always operate at the optimal level. So the products for AC, when you setting up your frequency, you would see that you can use 40 megahertz and higher. So you can actually select channel that would be in a wider range of your frequency. So I can select a certain channel, but ideal, you want to start with 80 megahertz and up. Okay. So if I select 160, all that does is it's going to bond the two channel together. That means that it's using each channel at 80 megahertz. So I have a double of that when I select the 160 and so on. Okay, so on the AC, it does allow you to utilize channels at a higher frequency compared to the older ones where your channel wide is a little bit less. Okay. So this gives you a little bit more graphic. So on this section, I supplemented from your text quite a bit. So I pull from multiple textbooks to give you these notes, and then resources online as well. Okay. Any question? No questions. Okay, so for A, it says, what is the benefit of dynamic frequency selection, your DFS in the wireless network? And you saw this is one of the feature for the classification. This allows you to prevent interference in your wireless network. And you know, it says prevent, but it doesn't mean that it stops it from happening completely, right? You do have, you know, so the best way that you can see this is when you're using like your microphone, and then when you're using your, you're standing there with your smartphone. If you ever hear like a pitch, right, that is actually a cross in the signal. And then you do, anytime that you have devices together, you're always going to have some kind of cross. Sometimes degradation is higher than other. Okay. So DFS allows us to reduce the interference that occur in the wireless network. Now, with the transmit for power control with the 802.11h, this is called the TCP. This allows the client to access communication with less power. We want to do this because we want to be able to integrate more wireless appliance and be able to maximize the resource. So what we see is it's going to use just enough energy to preserve and for the connection to the access point, and then it would reserve the power, conserve its battery power, plus to reduce interference for the neighboring wireless cell. So this is, you know, more on the industrial level or government use, you would see that this can be integrated. And I think that we should revisit this area, as we do see that, you know, we can support things with solar for industrial access point that you see across the city and town. Okay. So what that means is it's just going to charge the battery. Let's say that it's implemented with the solar panel, a small solar panel. It's going to use that solar panel to charge the battery pack. And that battery pack is going to be just giving out enough power to be able to maintain the connection. So when that connection is dissolved or somebody a device is disconnected from that, it would conserve the power instead of rebroadcasting. Because now, if you think about your wireless router at home, if you unplug your router, right, you have to give it continuous power. Okay, to really retain the information because it operates on RAM. Plus, like you know, and it's always broadcasting SSID because you can configure it to be able to beacon your SSID. So in that case, it continues to use your power nonstop to be able to send out, hey, I'm this router, connect to me. But in the case where we can implement the standards where it can only, it needs to establish that connection and then it doesn't need to do other things, then we can conserve more power. Any questions? And then for the MIMO, right, this is part of the feature for your antenna and your transmitter. So MIMO stands for multiple input, multiple output. And it uses multiple transmitter and receiver antennas to increase data throughput. So when it tells you that this is a MIMO antenna that's able to use in omnidirection, that means that it can go 360 degrees, right? And it's able to use transmit and receiver to send higher data rate. So you want that on your wireless appliance, okay? That's one of the added features for us to have more transmission, higher rate in transmission. So now let's touch on the testing of your 802.11, and this is from Wi-Fi Alliance. So for number 11, it says, Carlos bought a new wireless router and found the Wi-Fi sticker on the box. What does the sticker imply? And not all wireless devices have this sticker. Like I said, that not all of them been through testing, but they can be sold in the market. So that means that that particular router is passed through certification for 802.11 interoperability with Wi-Fi Alliance. Basically, they are an organization that's nonprofit to make sure that your wireless devices that's classified would communicate seamlessly, interchangeably. That means what? I can buy a wireless router from one brand and I can use it with other brands of adapter, right? Like I can buy a laptop and be able to connect to that. That's what you see. Okay. Now, if you buy a non-tested device, does it mean that it's not going to allow you to do that? No, right? Of course not. Companies want to be able to have a wider consumer base, more customer to be able to buy their device. So therefore, they want to make it interoperability, but they might not want to spend the money to pay Wi-Fi Alliance to test their device. So therefore, you might have an appliance that doesn't have a sticker on the box because it costs.
I've heard of that where this phone was made and it's technically like water resistant, but they have to go through the testing and they didn't want to pay to have it certified, so they were like, oh, it is water resistant. And it's like, the why is it not on the box? It's like, oh,
Not certified.
yeah, it's not certified.
Yeah. That's very common in the technical world, is that, you know, manufacturer, they will test their device so they can claim that, you know, it is like this. That's the feature. But a lot of times you would require an external entity to really validate that, right? And so Wi-Fi Alliance is that external entity. And sometimes, you know, companies don't want to pay an extra or go an extra step because it's time, it's resources, right, that they have to put forward. And if they want to cut costs, that's one of the areas that they can shave off. People will still buy it based on reputation, you know, lower in price, so they can lower the price and get more consumer that way. So they kind of weight the risk on that if you're looking at a business overall. Okay, so make sure we know what an AP or WAP stands for. Well, most of us know that, right? So here it kind of goes into different things. So your access point sometimes looks, it could be your wireless router can act as an access point, but your access point cannot act as a wireless router. It doesn't go the other way around. So make sure we read the specification. Okay. And then your wireless antenna would look something like this. So let's talk about some type of antenna. We already talked about omnidirection antenna with MIMO, right? So omni is in all direction, 360 degrees, and you know, all the way around, right? Even top, bottom, you know, not just in a circle. But so if you're using an access point that's omni, that's gonna send to everywhere. Then you see the Yagi. Anybody know what a Yagi looks like? You ever drive around town and you see those homes that have antenna on their roof? This was popular in the 90s. Okay. Now the new antenna for your TV is just a plate, right? But if you drive around like in some of the older homes, they have like these rods sticking up, and then they have like these spikes coming out, right? Those are the Yagi antennas, and they were really popular for like receiving signal. And then later on, people realized that, oh, I can actually buy a huge satellite and put it in my backyard and be able to get more like satellite TV. So you do see some of the homes. I see one of my neighbors has a huge one in his backyard. So that's how they were able to receive satellite back then. Now, like your satellite dish is tiny that's mounted on the roof, right? We went from something that's humongous to something that's less and something that's more compact. But Yaki is still pretty popular because it is a way that you can control point to point, especially in industrial area. So what do I mean? When you drive through towns that have like huge farming lands, right? How they can control their watering system and all of these things that, you know, sometimes they fly drones now to be able to detect like their crop stuff. I actually know a company, an owner of the company that he does satellite imaging for farming, where it senses like dry and flush area. So it takes pictures of your land, and then it does the heat recognition and images it, and it look at the spectrum. So if it's red, that means that it's dry. And then the farmers, they would buy this data, and then they would use that data to control how they flow water to water their crops. Because as you know now, especially in California, water is hot commodity, right? The government actually currently putting a lot of regulations on how they water the crops, or encourage the farmer to reduce their land use, and by, you know, paying them a certain amount to be able to not utilize so much land for the crop and watering for the crop. So what you see is Yagi is very common in that type of area where you can use it to control, like, you know, your watering system. Even like for pesticide systems, they use sprays, and now they don't just use people to spray anymore, they use machine that is automatically controlled by a lot of these appliances, because it reduces manpower, and then it can be autonomous. So what you see is a lot of the lands are actually, I've worked with one of my clients, he talked to me about like how to secure some of the smart devices for farming. And it was really interesting to look at IoT security in that sense. And so this is what you see in supply chain ultimately for cybersecurity, is that we have to look beyond, like, you know, the manufacturing company. We have to look at like the farming communities and things like that, and how they use, you know, wireless networks, and how they use IoT devices. Okay. All right, so this steps is just to show you how you can install. Don't be surprised that when you interview for jobs that they ask you about this, like describe the steps on how you would connect your wireless network. Most of you have used wireless so regularly, and we've done a wireless lab, so I'm not gonna go through this, but it is here if you need to take a look at it in specific. Okay, and then your basic service, which is your BSS. Make sure that we remember this, okay? So this is a mode of operation for access point, and it allows us to use in specific area, like making sure that our adapter is able to see the access point and communicate with the access point, and the access point is able to communicate with other hosts in the network. Okay, so that's your basic service. And we utilize the standardized communication, and ultimately your access point or your wireless centralized device is actually connected to the wired network. So you cannot have a completely wireless network. And I used to have students that ask me all the time when they do their project, can you go 100% wirelessly? You can now, right? But ideally, it should be like about 90-something% wireless, because you're still going to rely on your backbone, in which you can control a lot more on how you can scale and add additional device in your network. If I want to go 100% wirelessly, right, I have to find ways to make my router communicate with my service provider who requires wired connection, right? For us right now, unless you piggyback on like the mobile networks, which still is in the back, is still going to be wired. So we cannot remove the wired connection 100%. Okay. You can, but is their network wireless completely? Is my question for you. Okay. So now, considering that, we have to think about throughput. Okay. So your wireless network, is it, if you go 100% wireless network, you will, and then costs too. You will have more access point. The cool thing with this is it's flexible because it's ad hoc. You can bring your own device to work. And then on the security side, we would need to be able to control that a little bit more, right? For me, I think that wireless does open up some risk, but it is flexible for your employees, as everybody have mobile devices. But at the same time, like, you have to be able to centralize your control. Otherwise, you are going to have like a peer-to-peer environment, and it's not going to be good. So I'm going to tell you the scenario, and you can tell me, right? So in the case where physically it might not be possible to install wire. For example, historical buildings, they don't allow you to drill. You cannot add or have fault ceiling. You cannot have raised floor to be installed. So in a company, so for example, if you ever drive downtown Riverside or in a downtown area like Redmond, you're gonna see that there's all these historical buildings. And with historical building, you're not allowed to modify or put holes in the wall or, things like that without their authorization, right? You have to go through the historical organizations that, they overlook these buildings. And even if you own the building, sometimes you cannot do a lot of modifications to it. So because they want to keep it in shape like how it was, so then you cannot install a lot of these wires, right? So what you have to do is, so my work around that is, if they're allowing you to drill things on the wall, sometimes we actually put fault wall and then we run the wire behind it, to not attach it to the original wall. And then we would then have to use some wireless capability to be able to do that. Now, the challenge in that is historical building uses metal plates in their walls sometimes, and then that bounces signal. So you kind of have to, before you design that network, you kind of have to trace and see how your signal would be. Fluke makes great tools for you to do that. You can actually just run it. You walk it through the wall, you lean it against the wall, and it actually tells you, kind of like stud finder. So it will tell you like where the metal plates are, and then if you see metal plates. Sometimes, if there's an elevator shaft, we would run stuff through the elevator shaft, and that's very common for network installation. So I did plenty of cable my day. So, all right. So for number 12, it asks you, what is the transfer rate for 802.11 AC wireless device? And this is, the average, I want to say, your 1 gigabit per second, which is a lot higher than what you've seen, in the mega before for the other classification. Then for 13, it asks you, Paula wants to upgrade her wireless network speed. She purchased an 802.11 AC wireless router. In her home network, she's using 2 laptops that is 802.11n. It has those wireless adapter. What is Paula's system maximum transfer rate? How can she improve the transfer speed for her wireless network? So she has 2 older laptops, And the wireless router is able to connect to those laptops because it has backward capability or backward compatibility. So the laptop maximum transfer rate, and I'm saying maximum, right, that will probably be at 300 megabit per second or 450, depending on how long ago the adapters were actually released. So it was earlier on, you're going to see that it is 300 megabit per second. Later on in the 802.11n standard, they produce adapters and wireless devices that operate at a little bit higher in the speed. So you can see, you might see it at 450 megabit per second with antenna. Then to upgrade, that's simple, right? We simply upgrade the wireless adapter. So now you can buy the one that's with USB. You can buy the one that's actually attached to the port on the. So for me, I think for the wireless laptop, it's probably easier to adapt it through USB, and it uses power through USB and communication through USB. So it's great. And those come with antenna. I actually have some. I bought it for. Blue. These are not very expensive. You can, and as you look at these, right, it tells you the speed at even at 5G, much lower than what you see in the 1 gig that we talked about, right? And then we also talk about LAN and also the antenna types. So next time when you buy your wireless device, now you know a little bit more about that. You just make sure that you check the information because they don't all are always the same. Okay. So when you design your wireless network, we also have to consider, right, the scope of your wireless signal. That means that at some point you are going to have a gap in signal. Okay. So in question 14, it says, Max's office is 200 feet from the company's 802.11g plus U access point. Why is Max laptop transfer rate 15 megabit per second much lower than the transfer rate speed for that classification, right? It is because simply that he's just far from the source. So it is a degradation in your signal. So how can you fix Max's problem, right? We would need to think about the cubicle and the offices that are farther from the access point. We would need to put in an amplifier, right? Or a relay of the signal. So add another AP or add another amplifier for your signal. Now, in my experience, the amplifier for the signal don't always work too well. Sometimes it's probably you're better off adding another AP as it is farther away. Okay, for those workers. So it's like this. So let's talk about extended services. Okay. So as we know, it uses the set service identifier, which is your SSID. That's what you see. And this is going to be 32 unique character. So you can name it anything you want, right? And you can also stop it from beginning. You can always also stop it from sending it out to other device if you don't want that. So and for SSID, this is used to really identify your access point or your wireless router. Okay. Now, with the extended services, this is to allow you to have more coverage. So you do see the ESS being incorporated for things that are in wider distance. Okay. So in this example, you would see that we would have, this is our wire connection, right? And then we would connect to access point here. and then these system connected to our access point. So one access point, we have it at channel 1, the other one is channel 6. It's closer in the range because the overlapping is going to be 20%. So if Max is sitting here, he's going to get the least signal. Whereas if Max is sitting inside the scope of signal, he's going to get stronger signal, of course, right? So you want to set it up where it needs to have an overlapping like this. Okay, so when you design your wireless network, we have to think about how we would be able to have more coverage by extending. Thank you. Okay. Any question? Okay, so let's also define what a thin and a thick access point is, right? We learned about coaxial when we talked about thin net and thick net before. So in your wireless controller, what we want is remember that I said that it needs to be centralized. There got to be a way that we can control all the access points. So if you have 100 access points in your network, you're going to have one system that's going to control those, right? And we would apply security policy on through that particular system that's centralizing all of these. So comparing this to a centralized environment, you would have one that's going to control the others, okay? So that allows us to be able to control access. That allows us to be able to control other things like the services within. Compared to something that's non-control like this, that's going to be standalone, everybody is its own. This is going to be very difficult. A lot of the small businesses that I work with, whenever I come in and I find a wireless network, I always go back to this. I'm going to be like, well, you know, you got 3 separate things because you just add an access point and you keep adding an access point. And at one point, one of the attackers is going to come in through an access point, and then they're just going to drop a ransomware and there you go, right? So what you want is you want a way that you want to centralize your security by creating a controller for your access point like this, okay? And that's going to connect to your backbone, and this is your terminal to manage these systems, okay? So that way we can set up zone, we can do a lot more with this compared to this, where they're all peers, and then they can all be different or the same, but at the same time, it's harder to control. Okay, any question? So on your thick access point, that would be an access point that run a full operating system. Okay, whereas the thin access point, that's going to be a lightweight one. It doesn't have a full OS. Most of your devices that you see in the market now for AC is embedded Linux. Okay. And so if you buy like Cisco for, medium-sized to large business, likely that you would have the OS. It is managed, right? So you can have a graphical user interface with an operating system, likely that they use Linux in the back, and then they modify the interface so you can click and point and so on. Yeah, embedded system would be thick. Yeah, anytime that you deal with the OS with your device, that will be your thick AP. But not all AP comes equipped with that, right? It varies from manufacturer models, the scale for use. So on 15, it asks you, in wireless network, what type of device connect all components together? That will be your access point. But the access point is not your router always, right? Because your access point connects the device, your router actually connects and routes out to your service provider. Okay, so the type of antenna that's used in your access point is your omni antenna. You want it all directions. The type of antenna that used to connect two access points together, 1-to-1, that is going to be your Yagi. Then two example of an ad hoc network, and you see this a lot, right? Whenever you read about wireless or when you see a job description that requires wireless responsibility, it says be able to, configure, install wireless ad hoc network, right? So what is really a wireless ad hoc network? And how would you be able to install this? So you have two computers that are connecting wirelessly using their adapters. You would start, so I have two systems. Let's say that they don't have wireless adapter, right? Like your PC, your desktop at home. And then if I want them to be connected, then I would install the wireless adapter to those, and then you would configure ad hoc settings. And ad hoc settings simply that, it's just going to be that they would change periodically. It doesn't have to be exactly the same configuration or the same connection, communication channel or things at the same time all the time. And then for 19, it says Mark is installing a wireless network for a small business that consists of an access point, a small business server, some laptops, wireless printer. What type of wireless network is Mark installing? And this should be an infrastructure mode. The reason why it should be an infrastructure mode instead of an ad hoc network is that you want to be able to control the resources when you have server and printers that are there, right? And other things like your laptops. Even for the small scale, we want to put it on the infrastructure mode so that way we can control how your devices are accessed inside that network, such as printers and servers. Okay. Any question? All right, so after it shows you the mobile hotspot, what that looks like, and I think you can use your mobile phone now as hotspot, right? But it's risky, so just be careful when you do that. So we talked about signal degradation. We talked about things that prevent you from getting full signal, distance, wall, other barriers. So in the range of your wireless network is going to be, it could be as low as 25 feet. Okay. So in some cases it would control, you have to be able to work with the distance that you're dealt with, especially pertaining to physical space, the protocols that's used, the standards that's used, and then other things that are interfering, like other devices that exist on the network. Okay. Then you have Internet of Things. So let's go through these real quick so you know who they are or what they are. Z-Wave. This is for home automation. Okay. Such as when you drive up and your garage door open for you, your thermostat turns on, like a lot of those, the Google smart devices and the other smart devices, it uses Z-Wave. You probably hear it in their commercial and probably be like, okay, whatever. But it is actually that technology that's used for home automation. Home security system, thermostat, windows, locks. You've seen like Amazon and now Walmart, everybody's tapped into this. We can come to your house and put all the delivered goods inside your home in case you're afraid that people are going to steal it, right? If you can use our smart lock system and so on. So the smart lock system, and you see this abundantly in a lot of the other countries, right? For example, like Korea use quite a bit. A lot of the residents require smart lock, and so on. Garage door opener, and then your Ant Plus. This is for sensor data. This is often used in like biosensor like heart rate, bicycle pressure, indoor lighting, television. So a lot of the devices, even wearable devices, have ANT plus technology. And then everybody knows what Bluetooth is, right? So Bluetooth is named after the Viking king who had Bluetooth. It's a way that we can bridge device communication wirelessly. So this is discussed in the earlier chapter. Your NFC, your phone has this capability. We use this to, if you ever use you know, to be able to share screen and watch stuff from your phone to your TV, you use actually NFC. I use NFC sometimes to control other device. Now NFC also, if you pay with tap, you ever pay with your credit card, you tap your phone, that's NFC, right? So your chip on your credit card has NFC capability. So when you tap your payment now, you know that you use NFC. Then you also have IR, which is infrared. This is used a lot in tagging and inventory tracking, library books to products in store. And then it also uses RFID for asset tracking. So IR is also used in a lot of security camera too, for various area. Okay, so now you see a lot of, so this opens up a whole new area for security, and this is always changing, right? There's always some kind of firmware issue. There's always some flaw because we haven't gotten a way to really control the standardization in testing for these devices on how they are produced and manufactured. You know, and then there's some issues that products from overseas, and there's a leak in firmware, and then it caused a lot of problems for the consumer that use these products across the world. So what you see is that, you know, and then manufacturing area uses a lot of IoT for automation. Hospital uses a lot of IoT to do stuff for patients, things like that. So this is a, you know, if you're interested in this, this is a rapidly growing area for security. They don't have enough people engineering and testing and reverse engineer these areas. So you will need to have a little have background in electronics, and then programming, and then hardware is needed for a lot of this area. I always find it really interesting to really tap into IoT because, you know, it's always growing and changing, and it's an area that we truly need to address. Okay. So for configuring wireless LAN, after you had connected and you set up, we did a lab on this, and your book is this is from your book, and this is a Linksys, you can tell by the screen, and that's owned by Cisco. We always want to use WPA2 enterprise or personal, enterprise for the business. Okay, so let me move down to the next part. All right, so for 20, it says to ensure that the user is able to access wireless signal, what is the recommendation when installing multiple access point inside the network? And the next part of the notes is about site surveying. That is really important in networking. So for 20, to really address that question, we want to say that all access points should overlap signal by 10% or higher. And you saw in the picture that we are overlapping at 20%. It's for those people who is accessing the access point at that gap, right? In between the range of your network from one access point to the next. And use your overlapping channel, and that should not be these. Sorry, if you put these down, that should be your 2, 5, 7, 10, you know, those overlapping channels. So look at the prior pages. So don't put the 1, 6, and 11. Those are non-overlapping. So you want to use the overlapping channel on each of the access points. So for those access point in general, if you have overlapping area for signal, use overlapping channel, and that's what they're named for. And then for 21, it says, what is the main difference between wireless standalone and control-based wireless networks? And how are they configured? We talked about this, right? Your standalone does not have full OS, and they are managed independently or individually managed. Okay, so they are all peers to one another, and you have to, configure them separately. That's, as you have more, that's gonna create a lot of issues in mismatching and things like that. The control-based system is a full OS, and that's a thick AP. You want to have a controller that is configured to manage all the other APs. And in the grand scheme of things for enterprise, this is very important. Okay. We don't want to configure 100 APs. We want to configure one and be able to manage the others. And you can use software management tools and then SNMP, so software network management protocol on a specific server to be able to do inventory and track those systems. Okay. And it could be an appliance. It doesn't have to be a computer or an access point. All right. So when these are some of the things that cause the signal degradation, we saw distance, right? The further you are, the less signal you get. Some of your walls, especially metal plates inside the wall. Thick brick walls sometimes cause a problem. Most in California, you don't see this issue a lot because we don't use brick for our construction here because of earthquake, right? But in the historical buildings, sometimes you see that. And then protocol limitations and other interference. So I should say interference from other devices. So I'll be clear on that. Questions? So a few of my former students from last year, after they took this class and they did the practice test, they actually sat for the network plus and passed. Okay, this is one of the harder certification compared to CompTIA A+, right? Or Security Plus. So if you're interested, I have voucher. If you're in the apprenticeship program, I can give that to you. Okay. Question? No questions? All right, so I'm gonna talk a little bit about site survey so we know, and this is part of your job. Okay, so before we deploy any, that means we implemented the network, we have to do a pre-deployment site survey. That means that we would connect the access point and verify the distance. That also means that you would use your wireless device and you would walk, right? 100 meters that way, 100 meters that way, and make sure that when is your signal degrades. Especially when you work with warehouses, right? A lot of around here, they install access point, everywhere. So whenever we do network installation, before we roll it, right? Let's say it's a brand new warehouse, nobody's in there yet. You're there to install for the job. So you have to make sure that you walk through and you check. And then you test it by connecting devices. So you have to do a pre-deployment testing. So that means that, I want to test to see if 125 devices connecting and how it's going to be able to handle that. Right. And then after we bring people in and start working, then we still need to do a post-deployment testing. So normally that's like the first 3 days or the first week that the company, so let's say I have a new company, I installed the network, I did the pre-deployment testing, then the first week that they started using the equipment and adding their mobile devices and things like that, that will be your deployment. No, post-deployment testing is that you want to confirm that everything is working. And then after that period, it's going to be your maintenance and support, right? So there are certain phases that we go through in IT project management for infrastructure. So you need to do these 2 steps, especially for the wireless side. On the wired network, it's the same thing, but just wired, right? You got to make sure that once you roll, you have to see how it's going to fit. There's always something that's gonna go wrong the first couple of days. I'm gonna tell you that. No matter how well you prepare, that's why like when people say when we go live on certain system, it's always intense because even if you prepare, right? There's something that's either missing or something that could go wrong. So you just have to have alternate plan and be able to make sure that you can recover quickly. Okay. So we need to think about capacity. And so as you look, right, we want to have the overlapping in the radio frequency like this. And then we want to plan with the channel like this. You see 111 non-overlapping, right? 6, 1, 6, 1, 111, so on. So now if you're looking at the floor, that's like this. So we want to the beginning and the end of your channel, right? And then the mid and then the end. So when we go from the first to the second floor, you do see how the access point is set up. Now, if you want things to be, now notice that they're not overlapping. So if you're using overlapping, you're going to use the channels that are overlapping like 2, 5, 7, and so on. Okay. Why would we want to install something that's not overlapping like this? What do you think that is? So if I have a second floor, let's say that is dedicated to the finance department. Why would I have 2 access points that's not overlapping? What is that used for? Separate network, like management and then employees. Good. Because sometimes we run application for that specific network, right? Like for example, when people qualify for loans, I did plenty of installation for dealership. So when people qualify for loans, right, it goes into different phases, right? So, you know, the sales guy, they pass it over to whoever that's handling your loan paperwork, and then that goes through like multiple channel of authorization, right? So it gets into the management side. So what we want is we want like the sales and the customer side on a separate one. And then once they put in the information into the database, that gets in the back server, we handle all of that and then send it to the other network. So the manager can access it and they would authorize the loan and then release the sale for the car or whatever, right? And so you do see, you know, things, school does that too, like the student side and the staff faculty side. You see plenty of separate network this way. So you would use, right, non-overlapping channel to create non-overlapping networks. And then if you have like 4 floors that use overlapping, then we just install the access point like what we've seen in the other picture. Everything's overlapping with the other channel. Okay. All right, so now, we're almost done, just the last one, and then I'll talk about the lab that you need to do. Okay, for 23, before installing wireless network, what should you consider when doing the site survey? So when you do the site survey, these are the important things that you need to remember. Your network scope, that means the size that you need, how many devices and things and people. Right, remember that when you plan, like let's say all the employees have laptops that's given by the company, but remember that you're gonna have other devices that they bring to work, right? Like their mobile phones, their tablets, things like that. So you want to scale that ×3. Then the types of network devices. So you got Android, iOS, you know, Windows, etc. Okay. And then the compatibility and the capacity. Okay, the number of devices, how big and small your network, what kind of throughput, what kind of data you need to handle, all of that needs to be considered. And so for the network engineers, this is the area that they looked at. I've had students that have gone through and got an associate degree, went and worked as technician for a few months and became network engineer after 6 months, and then eventually moved into security very quickly. Some of those are now, you can find them at San Manuel. If you ever work for San Manuel, you know, you can go in there and say, Casey went to high, and most of the team there will probably know me. I used to teach over in near Catholic San Bernardino. And then you know, so you need to kind of plan and design the networks. Now, the security side of the house, you come in and you assess the network architecture, right? You think about like what can I do to really fix without ripping out everything and redesigning everything. You kind of have to patch the things that they have. So you have to come back to some of the concepts. And so this is why, you know, IT or networking and security is always better. Networking is my jam. That was my field area for a long, long time. So I truly love it. I do love security and it's always changing, but you know. So get good at this and you can do well in this. Okay. All right. Okay, any question? Okay, so let's talk about the lab that we had to do. So if you need to catch up, I put a page here, okay? And these are some of the things that I want you to work on. If you haven't done your packet tracer training, some of you did it and I gave you credit. So I will check at the end of the week and add. I won't ding you for late submission, but what I want you to take away is to know how to use packet tracer, just not to do it because the assignment is due, but it's just to make sure that you know how to use it. Okay. We also need to start our network plus practice exam. It is not due until later on, right? And I'll show you that, but make sure that we would start. Do not wait until the last minute. And if something goes wrong with practice lab, then we're gonna scramble for scores. So do it, give yourself time, do a little bit every day. So you remember, because if you're in a rush, this is a lot of information to digest. So treat this as if you are actually taking the test. So do the learning mode and the exam mode as if you were taking the test. And if you score high, then you're ready, okay, to sit for the test. And I encourage you to get at least 1 or 2 certification throughout this program, because without it, you're going to have a hard time getting work, even for the apprenticeship. So the apprenticeship, that leverage is always going to be top, okay? All right, let's talk about practice lab. Some of you already knew this if you took my online classes before. This is your cloud lab environment. You don't have to pay for anything. This is covered by regional funding. So that means that we're sharing this cloud lab with other colleges. So it does get crowded on there sometimes during the day or sometimes at night. So if it hangs a little bit, now the company tells me that it's not as bad as it was before they purchased it. So they recently changed ownership. Okay. So we are going to click this to access it and then follow the procedure on the left. It will tell you step by step, and then you just follow it like how you follow my lab exercise. You have to complete all the steps because they programmed this to give you 100% if you complete everything that's asked. When you finish, make sure you click the done button. Now, if you click the done button before you do all the tasks, it will give you the percentage based on what you have complete. So if I only did 15% and I just skip forward to the other pages and click done or finish, it's not going to give you the higher percentage. Okay. Now it does in the past, and I haven't seen this problem recently, but it does take a little bit to sync between Canvas and practice lab. Okay. This is a Java issue that they, you know, they said they fix it, but in the case you come across, so all else, anytime you complete the exercise, screenshot it and save it, just in case, okay? Especially with your practice exam, right? If you're getting a score and it shows 89 or 90%, great. You finished the part, take a screenshot of it and save it. In the case that it doesn't show up, you can email it to me so I can manually do it. As this is a regionally shared license, I don't have access as an admin in the back. So I cannot see who did what and what did what, okay? So make sure that, you know, just on the safe side, it is cloud sometimes have issues. So, you know, it doesn't matter what product you use. All right, click on this. And this is gonna load like this, okay? So ACI now own Practice Lab. Practice Lab is abundantly used. So it's gonna tell you that this is the steps. This is Okay, it's this assessment. It kind of freaked me out a little bit, but it's not. Okay, so what it tells you all of the things, right? This is gonna be an hour. This is the type of assessment. Want to make sure you know how to do it. Just go next. Look at this diagram. So it shows you the router, right? This is the 2911 series router. Look at the connection that we're using, right? Remember we talked about serial. We're talking about fast Ethernet. And so it's using fast Ethernet and serial. So this gives you the overall logical layout of your networks. Okay, so in case you missed last week lab, you can still do this one and get a little bit of practice in your CLI. All right, and then after you see that, you're going to go next and it's going to open this up. Now, each of these are your appliance. Okay. The cool thing about when they upgraded this, they actually make it a little bit easier. So just like your regular appliance where you have to toggle or press that button on, which one that you're using at that step, make sure you turn it on. Okay, so just click the drop down menu and then click turn on, right? And then when you're done, you can turn it off. And then you can also, close all your device operation with the power button. So it tells me in the step one, and I'm only going to demo for a few steps. So kind of give you the brief overview of the few steps so you know what to do. So it tells you to do the NY access one. Remember, we talked about how when we can use host name to name these routers, right? Normally admin, they would name it based on, location. Sometimes they schematically name it this way. So you would turn on the NY access one. So go here and then power it on, right? It's going to take a second. This is going to pop up. So this would be ideal if you have like two windows, left and right, just like how we did with the lab, to be able to see, right? And then it tells you that this is what you're going to see as the output. So once it boots up, just like your Cisco device, and they told me that when you turn this stuff on, it's actually a device that's being used, not a simulator, okay? So you actually booting on the device, and they do have a number of access limitation on those devices. So once you turn it on and get it on, then normally you saw this, some of you saw this on the appliance last week. Do you want to start your initial configuration, right? You can say yes, and it walks you through the step, or you can say no, right? So here we would say no. So it's going to open up the command line for you, and you would type in the command, okay? And then it's going to give you the warning for the secret. And you're going to see, just like what we've done before, we learned before, in order to configure, we have to enable. And after we enable, if we configure, we got to go config T, right? So once you enable, you type in enable, it's going to change that arrow into your hashtag. Remember, right? We saw that last week. And then you would do a config T or configure terminal. Okay, so type in configure terminal and press enter, and it's going to change. It's going to put the configuration. So if you get lost, always look at the path that you're in, right? You can only see configuration once you exit it, but you can only change the setting when you're in the configuration mode. So you have to enable and go into config terminal, okay? And then this gives you more exposure to VLAN. I know that we did a little bit of VLAN last week where we create VLANs. So remember, when you give it an ID like VLAN 10, and then in this one, it's pretty cool because you're able to add in, specific users and things like that. That's what you want to learn. Okay. So once you put in the ID for the VLAN, it's going to create the VLAN. And then you are going to put in the users, and then you're going to exit. You're going to do the same thing for the next VLAN. You're going to put in the department that's using that VLAN, and then exit. Okay. So when you name the VLAN, you just say name, right? Name the VLAN that's going to be the users. So one virtual local area network is going to be for my users. The other one's for my finance, and then for my servers and so on. Okay. So once we created all those VLANs, then we are going to exit and come back to the beginning so we can display the VLAN brief. Most of you did this last week. This should not be new right now, right? And we've seen this before in our assignment. So to display, it's going to give you the VLAN table like this. Okay. Last week, I actually made you tie it to a port, but you can just pre-create your VLANs and then you can configure it later. Okay. Then once it goes through, then now you're going to tie it to a port, right? I like to actually use the port first because that way, like, I don't mix up the ports later, but the way that this lab is written, this, you know, you can do it this way. You can set up a bunch of VLANs and then go through. In my opinion, I did network admin for a long time. When you do it this way, you can key in the wrong thing and it's tying to the wrong VLAN because you're doing 10 VLANs at a time, right? So I normally configure one VLAN at a time. And then I would go through and complete that VLAN until I set up the next. But they show you how you can do like multiple names and then you would go in and you would put in the ports for each of the VLAN. So this way is okay too, okay? And then once you tie a physical port, which is a connection point to it, then you are going to use the switch port mode access. You always want to use this command when you're trying to set up your port switch, okay, your port for that switch. Okay, so now I'm going to say, I'm going to change the mode to access for that port. And then I'm going to tie VLAN 10 to that port. Okay, we didn't get that far last week because we did a lot of other things, right? Like getting your stuff set up and be able to configure it with PuTTY. So doing the cloud lab is great. You can get a lot of steps done, but you don't have the exposure in how you can terminal into the system using PuTTY and how to fix the common physical issues that you have. Okay, so when you go through this, and then every time that you finish configuring, it's always a good practice to come back and show to see if it create and store the setting that you put. Okay, because if you can do 100 of them and nothing is changed appropriately, then you have to do it all over again. So it shows you how you can go in and look at the changes. Okay, and then so when you do these steps, think about what you're doing, not just because you just want to do the task and just to be done. Okay, and then after we're done, then to configure more, remember now you're going to access the VLAN as an interface. So we would say interface VLAN. And then through that, we can tie an IP address in. Okay, so we did some of this also last week. And then no shutdown, you saw that. And then you can also use N. Now, some Cisco switch don't take N. Just to let you know, certain model, right? I think some of our new models can only use exit. Some model would take both. So on this model, they're using the 2911, which is kind of earlier on. So you would see that, okay? And then we want to ping it to test the connection, okay? So this takes you a little bit more further. I tried to take you to trunk. I did write another lab when we use VLAN for trunk. But if you're already doing this lab, we're going to focus more on routing as Cisco routers instead of like VLAN switching and stuff like that. Okay, so go through the step by step. It's really easy. They also show you what it should look like. And then as you practice, you will have more, experience. So now I'm going to go to the Encore 2. So I turn on the Encore 2, see how it's green, right? And be able to start working on that. And then when I'm done, I can just turn it off, power off, okay? So there are 5 pages to go through and just a few steps on each page. And then make sure that if it does ask you for certain things, right, like screenshot, then you make sure you do it as the instruction is asked. And then when you're done, and I'm using a module that's for the newer Network Plus, okay? So it's not like dated or anything. The cool thing with this too is it's also going to show you a little bit on configuring for voice, like VoIP, but voice over IP itself should be its own course. Okay, in my opinion, like when we lump it up into like switching and routing, voice over IP is its own certification before, and so it has a lot of details. So it's gonna go into some of the things that we talked about, is about spanning tree with flow control, and then submit some of the answers to what you've seen throughout the lab. Okay, when you're done, sorry, they changed up this button to complete. Make sure that we click complete, and then it will give you 100%. Okay. So this one, at least everybody can do it instead of doing it in groups. But you know, there's always advantages and disadvantages in this. Any questions? Okay, just one more thing. I know. It's coming to the close. Let me get out of practice lab. Let me turn this off. Maybe not. I just need to turn power off all devices. Okay, so before you close, you just need to power it off. Move this bar and then close. Now you can come back to it and you know, at a certain, but it doesn't always remember where you were. So you can like just do some part and then come back, but I recommend it sit all the way through your lab. Okay, let's talk about your practice test. This is part of your overall grade. There is a percentage that's dedicated to your practice tests. When I teach this class, taught it long time ago, I normally make student build a network and design a network and all of that. But I think essentially for your career, it's more important for me to focus on getting you through the certification. Okay, so this is due on December 4th is the learning mode. It's the same practice test, but they do use a pool and they pull different questions. So even if you go through this, the question might be different in the exam mode. Okay, and this is also through practice lab. So you are going to click the below link and then you're going to start your learning mode. So it's going to look like this. Most of you are familiar with this as you took classes with me before where I required this. So on the learning mode shows you like, but this I'm using the older one. They don't have the 08 release yet on practice lab. So the questions are going to be really close from the older version to the newer version. They are, CompTIA is using some of the old questions as well. Just their pool of questions got bigger and they integrated new technology questions. Okay, so that's fine. You can go ahead and click start, right? And this one, you can, you know, ideally we want to do 90 minutes, 90 questions. And it does take a little bit to get started here, so sorry. Now, when you're done, you can also click view reports. It's going to show you your progress. So here it gives you the breakdown of different domains that they're asking, right? Like the infrastructure, operations, security, troubleshooting, and concept. So we're going to click continue and I'm in learning mode. You can always restart it. If you feel like, oh, you didn't do as well and you want to relearn, just start all over, right? And then so once I click start, so simply I can go through, read the questions and then pick my answer. And then I can click show answer and then show explanation, okay? So your objective in this is to get 100%. Right? I would try to answer the questions without looking at the answer, but if you need to see the answer, it's there. That's the learning mode. Do this one first. Okay? So once that's done, okay, and you don't have to wait until December to do it. You can do it a little bit here and there. Then you're going to come back to, let me go to the module so it's easier to find. You're going to go to the exam mode. Okay. Some of the students in my other classes, they like to go for the exam mode first and then they realize, oh, you know, I have a lot of missed questions. This is not due until the 11th. So you do have a little bit of time, but this one, treat it like a real test. Okay. In practice lab, there are 3 modes: learning mode, assessment mode, and exam mode. So the exam mode is like almost like the real test. So it tells you this is time, 90 minutes, 90 questions. There is no way I can slow down on this. I have some student that email me about this with accessibility, that they need additional time. What I can do is you can take it as many time as you need as you require, but because it is simulating a real test, so I cannot give you extended time. Okay, I did write practice lab and ask about that. And they said that because CompTIA, accessibility is a little bit different in the request. So, your pass score is 72%, aim for 80 or higher, because, they always moving the target goal, and you can always view the report. So once you start this, sit through the 90 minutes. Okay. And then, yeah. So if I don't want, if I, I want to, let's say I got 70%, I'm not happy, right? I click start over, and then it might not give you the same questions, okay? Because they're pulling from like 900 plus questions. So the computer is going to regenerate the text in a different way, right? It's going to randomize the questions. So now CompTIA does the same thing. When you resit for the test, if you need to retake the test, you might not even get the same questions, right? As they move on to the newer version, you're going to see that the question pool is larger and larger and larger. Okay, so we'll just click start, and then the same thing. It's all multiple choice, right? But this one doesn't show you the answers. Okay, so do your best on this. See, this is always going to come up. This is one of the very common questions in collision detection. Okay, I remember from like way back in the day when I studied for the Network Plus, it was the same questions back then as it is now too. Okay, any concern or questions or comment? Okay, so with that, we are gonna stop share. We're going to end my session.